question that we're going to ask, that I'm going to ask here, and with in a very modest manner, not claiming any kind of theory on that, is can and will algorithms replace lawyers? And to a certain extent, this is happening all over the spectrum. Algorithms are replacing human beings, partly. Okay, in some of the tasks, in particular, all the tasks that are very repetitive, we know how to do that now with computers, and it's much, much better. Why do you do that? Why would you use algorithms? First, is to reduce costs, to facilitate life, to improve the functioning of something, in particular here law. And I don't want to talk about that in more details, but the main question is ultimately, does that mean that lawyers will be replaced? And that's a very interesting question in general for any kind of profession. If you ask someone, will your job be replaced? They always think their job is going to be the last one to be replaced. I was interviewed by in France Inter, and the guy told me, no, you're not going to replace journalists, of course. And I told him that's probably what the taxi drivers thought at some point, okay? So, yeah, I'm sorry, we can do a lot of the work that you're doing now with computers, essentially like we can do also, I'm a professor, and you can do a lot of the work that teachers are doing using computers now. We cannot replace completely them, but we can do some, and more actually. So big data, you've had already a nice introduction to big data. I'm not going to insist more on that. You know what we're talking about. Difficulties being essentially to detect causality. That's much better in detecting correlation. It's not exactly the same thing. Machine learning, that has been mentioned too, and I'd like to basically restate a little bit what this is all about. So the first thing is when you really know some problem and you know a solution to a problem, you can write an algorithm, you can design an algorithm. So it's really something that you understand, that you have conceptualized to a large extent, and if you want to send a rocket to the moon, you know how to do it, and you can write algorithms to do it. But there are certain situations where we don't know how to do that. Okay, and actually very simple situations, like if I ask you, how do you recognize a cat from a dog, you're going to have difficulties explaining it to me. You're going to say, well, the tail is not exactly the same. Well, what do you mean? And so on. So we don't really know how to recognize a cat from a dog. Computers, we as human beings, we learned that actually from very, very few examples when we were kids. Computers today learn that they require hundreds of thousands of examples of this is a cat, this is a dog, this is a cat, this is a dog, and eventually at the end of the day they are reasonably good at recognizing them. Not as good as you are, but reasonably good. So that is machine learning. So it's a very experimental science. There is no big theory of machine learning. If you believe that at some point this was a beautiful advance of computer science, yes, it is, but it's very pragmatic. It's just by experiment and attempts and errors and progress. And essentially, the way it works is that you give lots of examples, and the machine learns from the examples. Therefore, the name machine learning. Okay. Now, why do you find that a lot in human sciences? It's because we are humans. And as humans, we are not very precise. We don't know how to specify everything that we're doing. We just have many examples, and based on these examples, the machine has to learn. And that is not easy. Okay. So, the fight between machine judges and human judges. What I'm going to do from the rest of the time I have, I'm going to talk about advantages of algorithms. And when I talk about advantages of algorithms, it's versus human lawyers or human judges. And it's not to criticize the humans. We know that this is difficult. And then I'm going to talk about difficulties of algorithms, and it's not to criticize algorithms. It's the same problem. The problem remains difficult if it's done by machines. So again, I'd like to warn you from people who tell you that computers can do everything. That is not true. I'm a computer scientist. I'm very modest. There are lots of things we don't know how to do. And for the moment, we are extremely, extremely, extremely far from being able to take a human judge and replace it by a machine. We can replace them for very precise and specific tasks, tasks such as prediction, things like that. But in general, we are very far. So this is a little bit science fiction. This is going to be the science fiction part of your conference. That's what happens when you invite computer scientists. First advantage of algorithms is transparency. We learn and we used to that, but the human decisions are typically very opaque. Okay, maybe they're going to tell you I decided because of this, this, and this, but is this really true? And of course, it's not possible to list everything that make you make a decision. So there is some kind of opacity in a human judgment. Okay. When you have an algorithm, you are forced to explain what the algorithm is doing. You have to explain the parameters, you have to explain the laws that are guiding the algorithm and so on. So that is forcing us to be more transparent. And again, this is not by nature. You can write a very nice algorithm and hide it and don't tell anybody how the algorithm works. That's not transparent, okay? Being transparent is actually telling exactly what the algorithm does, basically by making it open source. Also by making the people in charge discuss what the algorithm should do. And I'm going to take an example that the French audience will understand probably better, which is APB, the post-baccalaureate student assignment in France. So we have this huge system in France. It's very particular to France. At the end of high school, all the students go to a system, they say what they want to do, and then the administration decides where to send them. Okay, it's huge. I mean, imagine all the students from high school at the end of high school. Now, it used to be done by humans. Now it's done by an algorithm, and that has created a lot of fuss. Now, if you think about it, the fact that it is performed by an algorithm that people criticized actually makes the entire thing much, much more transparent and in a way fair. You cannot just call some friend and say, well, I'd like my kids to be pushed to that school and so on. This is, in principle, fair. The fact that it was transparent isn't clear because at the beginning, only a few people in some office knew the algorithm. And after some fight from student unions, the algorithm was made public. And that's the first step. The second step now, it should be discussed. And people can actually discuss what's in the algorithm and make it not the decision of a few people, but the collective decision. So transparency, first advantage. Second advantage, fairness. Don't have to tell you that humans can be prejudiced. Also, humans can be inconsistent. And there is this study that's shown that parole decisions are correlated with the time of the day. But when I heard that, I thought they were mildly correlated. If you see, I cannot remember the number, but that's amazing. I mean, they're amazingly correlated with the time of the day. It's way better that you come after lunch than before. So algorithms can be make blind to race, gender, everything you want, and they are by definition more consistent. Quality. You can write bad algorithms, you can write a good algorithm, but you can improve your algorithm. And essentially, it's interesting that we accept humans to make errors, and it's way more difficult for us to accept computers to make errors. And I'll take for that an example from outside the law system with autonomous cars. Okay. There are bad drivers, there are lousy drivers, there are tons of bad drivers. We all know that. There are drunk drivers. So essentially you go in a car and you're willing to drive, in Paris Saturday evening when there are lots of drunk drivers, and you're willing to drive in Paris Saturday evening knowing that there are drunk drivers. But if you ask a panel of people, nobody would be willing to drive if there are autonomous cars that make fewer mistakes, fewer errors, fewer accidents. So essentially, and that is normal, I'm not complaining about that, that is normal. With machines, you are expecting a higher quality. When you fly a plane, you want no accident, and for good reasons, okay? Now, an interesting point in that is that's forcing us to measure quality. I mean, we take as granted that judges make mistakes, but when you want to compare it with a computer, then you say, well, you know, how many mistakes do they make? Can we make a computer that makes fewer mistakes? This is the kind of question that you ask. Now, that was for the good side of the algorithm. On the bad side, the data the algorithm are going to decide on big data, and this big data is human data with all the problems that they have with this data. And I'm not going to go too much into the details, but a lot of this data is just the main aspect is a lot of this data is not factual, it's sentiment, okay? Computers are very bad at that. Computers are, you know, like based on logic, you know, it's true or it's false. When you start putting a computer with something that are conflicting opinions, it's difficult to deal with. I mean, I'm not saying it's impossible, I'm just saying it's more difficult. Second difficulty in particular with respect to big data is rare situations. Okay. Again, think about the technique that you're doing there is you're taking lots of examples and you're trying to imitate the examples. You're trying to do the same thing in a way. It's not very original, but at least it works. Now, the problem is how do you expect to react in front of a situation that's kind of unique? And I'm not going to take it from an example from law, I'm going to take an example from the financial world. Okay, people have trained mathematical models and have done simulations, computer simulations for the market. But typically, all these mathematical models, they require boundaries. Okay, they are known to work under such and such boundaries. Now, what happens if the market starts being wild and goes out of the boundaries? Nobody knows. Okay, so now you're in a situation where you can actually exaggerate the problems, because basically you are reacting to a situation that you're not made for. Okay? And that's a little bit the difficulty. It's not a little bit, it's a big difficulty of easy to work with massive situations, very difficult to work with cases that's going to be unique. And in law, there are cases that are unique. You're probably going to say that every case is unique, but I won't follow you there. Explanations, and that's a serious problem with the current technology of machine learning and big data in general. Essentially, you have a computer that computes. There's tons of operations, and at some point gives you an answer. Are you happy with the answer or not? I don't know. Okay. Now, if the question was, am I going to, you know, do I want to look at the theory halt and catch fire, which I recommend, by the way? That's okay. If I made a mistake, in the worst case, after 10 minutes, I'll switch and say, well, I don't like that. Now, if the answer is, should I get parole or not, then I prefer not to have a mistake, okay? So the question is that we're used to explain important decisions. And this technology has difficulties explaining. Just to explain briefly why it is so, there are different kinds of machine learning. The traditional machine learnings, humans specify features, and then the program tries to find these features, try to recognize this feature and base a decision based on these features. Now the features are human, are human understandable. Okay, I don't know, the stars are in this shape or in that shape, and based on that, I think this is we are more in this style of planet or not, whatever. Okay, this is something you can explain because the humans selected the features. With new methods in machine learning, for instance, deep neural nets, for instance, essentially this is not the case. It's so difficult for humans to specify the features that we decided, computer science decided, since we're not very good at finding features, let the computer find the features. So you've got a computer that trains, detects features. Now the problem is that the features are not human understandable. So, if you're told that the reason is that because feature 76 and feature 2033 were detected that you are denied parole, you may be unhappy. So there is some work in trying to improve that, but that's just ongoing work. So I'll just get to my conclusion. In my humble opinion, the replacement of human judges by machines is going to be possible at some point. I'm not going to tell you which point, how long. It's probably going to take long. I mean, don't believe this is going to come, in the next 30 years or so. And it's going to be fraught with pitfalls. The question, the real question, in a way, is: are we going to accept that? And are we willing to be judged by machines? And of course, there are things that are mechanical, simple, parking tickets, speeding tickets. That's okay. But for serious offenses, it's less clear. Now, there is a way out that you hear all the time, which is, no, there will be a judge, and the judge will use a computer to help. Okay. In my humble opinion, that doesn't go very far. It's useful, of course it's practical, and we're going to use that a lot, but there are certain limitations. The first one is humans are typically lazy. Okay, if the computer is willing to work and give an answer, why do you bother? But there is more than that. It's a question of responsibility. Let's look back at parole. Okay, if the computer comes back and say no, deny parole, as a judge, will you rule out the decision of the computer and say, no, you're taking a huge responsibility. If something happens, they're going to come to you and say, well, but the computer said deny parole. Why did you? And of course, you don't have any good excuse except for this my strong intuition. Difficult. So, take-home question. Suppose there exists an algorithm for deciding parole that is proven to do fewer errors than the best judges. Now, the first difficulty is you have to get this proof. But maybe you let them run for 2 years and you see what happens, and the computer makes much fewer mistakes. I'm not talking about little fewer, many less mistakes. So, what do you think? What would you do? Do you think it should be used? In that case, I'm going to say, well, how about appeal? Would you accept also the appeal to be done by some software? And the second thing is, do you think there is something fundamental in the human condition that says no, that this is a human responsibility to judge, and we don't want to let it to machines. So now we are not into efficiency. We're talking about philosophy, ethics. And I don't have personally an answer, and I think we have quite a lot of time to think about that before this happens. I'll finish by, for the French people, a little bit of advertisement. All this is based on some thinking we did with friends on the general change of the society in general, not law, but the society in general, with computers or with data. And the book on the left that we don't see because it goes a little bit out is Le Temps des Algorithmes that I wrote with Gilles Devecq, and that already appeared a couple of months ago. And the one on the right is Terra Data that I wrote with Valérie Peugeot, and that's going to appear at the end of the month, together with an exhibit at Cité des Sciences. Thank you for your attention.